Welcome back to Lecture 8 in GRA 6036. Now we're going to work with Project 10, this project right here. And so if you haven't tried to solve the project yourself yet, please do that before you watch the remainder of this video and the next videos. So, let's see. So here's my project 10 file, and as always I start by setting the path to my working directory. So this you have to change to the directory where you have downloaded and saved this CSV file or this text file that I've included because I've seen that some of you have trouble with the CSV files for some reason. So there is also the same dataset in a text file format. Okay. So now we have downloaded the beauty dataset. So before we start, it's always nice to have a look at the dataset. So you can do head beauty. That was not well spelled. So here we go. So here's the dataset. So the head function gives you the first 6 rows of the dataset and all the columns and also the column names. So you get a quick overview of what the dataset looks like and also the nature of the different variables involved. So I mean, you could also, to see how big the dataset is, you can use the dim function. So do dim beauty in this case, and you get this, which is the number of rows and the number of columns. To get the number of rows, you could also do nrow, which gives you well, only the number of rows. And you can do similar, you can do ncols, or ncol I think it is, which gives you the number of columns. So of course you could also just pick out the first element of the dim thing and also the second element to get the number of columns. So I mean, you could do whatever you like, but this is shorter. Okay, so then we start exercise A. So we are to compute the average wage for people with looks assessed to be greater than 3 and the average wage for the rest. So then we know that we should find the wage variable. So as we remember from, I mean, we can look here, there's a wage variable, and this is then a vector with all the wages. So now we're going to subset this vector, so we're going to pick out the wages corresponding to those people whose looks are assessed to be greater than 3. So then we use the square bracket thing to pick out those elements. So I mean, to get the element 1, 2, and 3, we could do 1, 2, and 3. So then we get the 3 first. We could do 1, 2, and 30, and then we get element 1, 2, and element 30. But you, instead of having the actual indices here, you could also have just a vector who is the same length as this vector with true false values. So to give an example, let's make a vector A with that contains the numbers 17, 3, and 9. So then A is this vector, and we can pick out the first element like this. Similarly, we can pick out the second element like this, or we could pick out the first element and the second element in one go like this. So I mean, now we're using the index numbers. We could also use true false values. So then we make a vector with true, and false. So this will, I mean, these two things will give us the same answer. So it's this thing that we'll do up here to get to subset this vector. Okay, so then we do beauty looks. So here are all the looks, and we ask which ones of these are bigger than 3. So then we get a true-false vector. And now we can just take this vector and insert it right here, and then we get all the wages of the people whose looks are assessed to be greater than 3. So this is a vector, so we can compute the mean of that vector by plugging that vector into the mean function. And similarly, we can compute the mean for those whose looks are less than or equal to 3, which is this. So we see that the wage of the people whose looks are bigger than 3 is somewhat higher than the wage of the people whose looks are below or equal to 3. So, okay, so that was exercise A. Then we'll do exercise B. Now we are to delete an outlying observation. So delete the outlying observation with a wage exceeding 60. So, well, right now we don't know that there is only one observation who has a wage exceeding 60, but we can, so we do beauty wage bigger than 60, we get a true-false vector, and we can then sum this vector to see how many people have a wage exceeding 60. So it's only one. We can then find the index number of this person using the which function. So we see that this, so the index number of this person is index 603. And we can then we are to delete this person from the dataset. So we'll delete the row corresponding to this person. So then I make a new dataset called beauty2, which is equal to beauty, where I delete this row. So I use the minus, and then you have to remember the comma. So this means that remove this row, keep all the columns. Okay, so we run this, and then we have a new dataset, beauty2. Now beauty2 is supposed to be smaller than beauty, of course. So we can do n row beauty, which is 1260, and then we can do n row beauty2, which is 1259. So we succeeded in deleting one row from the datasets. So then we are to recompute the average wage, what we computed in A, but for this new dataset where this extremely rich person is deleted. So then we can just take beauty2, and 2 here, and then rerun these means. So now we see that the people whose looks are above 3 has average wage somewhat below the people whose looks are less than or equal to 3, which is opposite from what we found in A. So we now see that the ordering of the means have flipped when we deleted this person. So that is the answer to exercise C. So, since the ordering of the means flipped from A to B, we know that the person with a wage above 60 must have looks bigger than 3, because it must be this person that contributed to the wage, the average wage being higher in the good looks group than in the not so good looks group. Okay, so now I'll make a new video with the remaining exercises.